Hello guys, Proximity Math here, and I'm going to go over the 2017 Aime Ii number 7. Just for clarification, this is the Aime Ii number 7. So it says find the number of integer values in the closed interval -500 through 500. For which the equation log of kx equals 2 log of x plus 2 has exactly one real solution. So it has exactly one real solution. I'm just going to circle that because it's important. So alright, so now let's solve the problem. Okay, so because we need a positive number in the argument of the logarithm, that means that kx and x plus 2 both must be positive. But if we move the 2 here, then when we're solving our log equation like usual, it would get log of x plus 2 squared, and that would always be positive. But here, we need log of x plus 2 to be positive before actually putting the 2 here, because otherwise that's invalid. And that's why we can't, it's not going to cause some problems if you put the 2 here, and we need exactly one real solution too. So the best method which I used too was graphing. And let's see, first of all, let's make the plane. Alright, so we need, first of all, the first equation is log of x plus 2 squared. And I'm going to clear up it so that it always fits in the argument a second. So now if we have 2 to the left of the origin, and if we have 2 to the right of something that's x squared, since that's just x squared shifted 2 units left, 2 to the right of the vertex is going to be 2 squared is 4. So it's going to intersect the axis at 4. Before. And let me draw an accurate diagram. So here, left and right, and equals kx. So first of all, since x plus 2 must be positive, we need x to be on the right side of the vertex, so that it's basically, so that x is greater than -2 and x plus 2 is positive. And if x plus 2 is positive, x is greater than -2, so it must be on the right side of the vertex. And that means we can completely nullify the left side. Basically, we can pretend it doesn't exist. So this is our parabola now, and we can take kx, and I'm going to draw multiple models. So let's say we had, it's going to be just a line to the origin with slope k. Let's say we have k being negative. This case is easier actually, so I'm going to go over it first. Now, this part is going to be positive because if k and x are negative, actually, if k is negative, it's only going to intersect negative x, and if it's positive, it's only going to intersect positive x. So we don't have to worry about the signs. But anyway, it's just negative times a negative, and that's going to be positive, so it does fit in. And of course, we took care of this part. So now, note that we're only worrying about this part of the parabola, and if we choose any negative slope of k, it's always going to intersect the parabola. And it's going to intersect at least, exactly one time. But we cannot have k equals 0 because we can't have log of 0. So k must be between, k can be -1, -2, or actually anything until, since it's in the closed interval, -500 to 500, it can only go until -500. So, okay, for the second case now, since this is a degree higher than the line, it's always going to intersect the line at a second point. That means our only case where it is exactly one real solution with kx and 2 log x plus 2 is where it's tangent. That means that we can figure out whether it's an integer or not. So let's see, on the left side, we need x squared I'm expanding x plus 2 squared, so x squared plus 2, 4x plus 4, that's the formula of the parabola, and equals kx. So that would mean, basically, we wanted to intersect exactly one point for it to be tangent, or to be tangent to intersect at one point. So we need this new quadratic. If we move the kx to the left side, then and put the right side to 0, we need this new quadratic to have exactly one real solution. And you don't need to go through any factoring or quadratic formula for that, because note that with x squared and 4 being terms that are unchangeable, and we're only changing the x term to make it x squared plus 4 minus k x plus 4, we just need to find another square. The only other square we can have is x squared minus 4x plus 4, with x squared and 4 being in it. Make sure you understand why. So now if you move this to this side, then 4 minus kx, that's going to be the new x term, and we want that to be negative for the whole quadratic to be a square and thus have only one solution. So k from this case must be 8, and I'm going to write that over here. So if k equals 8, and it can be any negative integer from -1 through -500, that gives us a total of 501 solutions to k.